So, good morning and welcome to this CNC Retrofitting webinar, The Benefits of Modernization. This webinar is going to run in partnership with Pantech Metrology, and Thomas Haeusle, the head of the business unit, and Joerg, head of the service for Pantech Metrology, are both here with me today to present and talk about CNC retrofitting. So if we just look at the agenda for today's presentation. So we're going to begin by having a brief overview of Pantech Metrology, a little bit about their background and who they are, and then of course I'll present an overview of PowerINSPECT, and then we'll move on to look at how you can make the most of your CMM, how you can make your inspections more efficient, and what are the benefits of CNC retrofitting. And Joerg's then going to tell us a little bit about his work and a case insight of some past customer that he's worked with, and then we'll have a demonstration from myself on PowerINSPECT CNC, and we'll move on to conclude the webinar by looking at what the key things are to look for in a retrofit partner. So without further ado, if I now hand over to Thomas, and he's going to talk to you about Pantech Metrology.
So thank you very much for your introduction, Michael. So who is Pantech Metrology? Pantech Metrology, with headquarters in Liechtenstein and customer centers worldwide, has been offering CMM hardware components to the metrology market for more than 25 years. With more than 14,000 installed controllers, we are proud to be the preferred partner of the industry. Nowadays, we provide complete integrated solutions consisting of control systems, probe heads, and a wide variety of probes to OEMs and retrofitters, ensuring with the design and performance of our products and services, unbeatable speed, highest accuracy, high flexibility, and ease of use. And all this not just for the OEMs and retrofitters, but also the end users. With our own expertise and also key know-how from strategic partners, we believe to provide best-in-class products and services which are designed to be seamlessly interlinked, and by that ensuring highest performance and state-of-the-art technology. From reliable controllers to innovative hand terminals and various models of fast probe heads and solid probes, we can offer almost everything needed. And all these with well-known Swiss quality, since almost all products are developed and produced in Switzerland, the heart of precision. So Michael, what then about PowerINSPECT?
Okay, thank you, Thomas. So we've seen there that Pantech is a complete solution provider with the controllers and the probe heads, and also the retrofitting service. So a brief background to PowerINSPECT. PowerINSPECT allows you to compare parts and tooling against all mainstream CAD formats. So one of the key things with PowerINSPECT is that we can work with 17 different CAD formats, which gives you the confidence to work with a range of assemblies from all of your customers. Furthermore, PowerINSPECT in general allows you to work with all device types. So whilst we're talking about CNC CMMs today, PowerINSPECT is also a powerful partner on portable CMMs, and we've of course got machine tool inspection. In the CNC arena, we're going to look at the collision detection abilities of PowerINSPECT that allow automated solutions to be run, and the embedded probing strategies. Furthermore, at the end of the inspection sequence, color-coordinated on-screen feedback allows you to evaluate the performance of your parts at a single glance. And of course, our reports are professional. You can customize them with your customers' logos, and they can be annotated with images to complement the data in the tables. So, CNC retrofitting, that's the main topic of today's presentation. Have you ever asked yourself, why are you not able to benefit from the new software? Or perhaps you can't open all CAD formats. Maybe you don't have the latest measurement techniques, or your measurement results might be inaccurate. Is your production complaining about time-related bottlenecks? Are your processes laborious? Or do you often have to call your CMM service? If any of these topics apply, then perhaps it's time to consider a CMM retrofit, CMM modernization. So Thomas, what does CNC retrofitting give you?
Well, you may ask yourself really, why do I need a retrofit on my CMM? Well, with a retrofit, you'll be able to use the newest software, like the PowerINSPECT software, the newest hardwares, like sensors and controllers. And also by having all new components, it will allow you to use your CMM with new measurement strategies and by that reach better results. Capturing programming can become possible and still have easy to understand reporting to reduce communication errors in hectic day-to-day jobs. Most important, with more capable components on the CMM, you can capture more points per second and measure more features, which will increase inspection throughput. And these all lead to more bang for the buck. Furthermore, you can have confidence your CMM can meet your future inspection requirements. It also makes your measurement sequences much more efficiently, and reduces maintenance and support cost increases, and by that increases profitability. Joerg, how can you get a retrofit?
Okay, how can I get the retrofit? First of all, you need a retrofit partner. To get such a partner, a good source is the Pantech website, pantech.com. And there you will find one of our most reliable partners for retrofitting. What happens after you have such a partner found? The very first step will be a machine survey. This means the retrofitter will ask you for your machine, which brand it is, which type, which year of production, and so on. And very important, which probes you use so far and you want to use in the future. After all the things are clarified, the installation starts. Installation can be very different, from only one day exchange the controller because everything else is fine, to some weeks because you have a very big machine and you want to renew the cables, use gates, and so on. Once the installation is finished, you have a machine up and running, but not accurate at all. So here we start with the next point, the calibration process. Means your retrofit partner now will start to laser the machine and bring it to best performance. And after this is done, machine is ready to work and completed. Hopefully the fourth step you will not need too frequently. This is the support time. Means after the retrofit is finished, you are not let alone with your machine, but if there are any problems, any issues, you can contact every time your retrofit partner and he will help you out here. Okay, let's see an example of a retrofit. I choose a machine with a ZMAS AMS, horizontal arm machine, really big, and as a special thing, it has AC motors instead of DC motors. DC motors are used, let's say, for 95% of all CMM machines worldwide. AC motors are not such common. So DC motors you can run directly with the most controllers in the world without an external amplifiers. For AC motors you need these external amplifiers. Why the customer was thinking about making a retrofit? Because he was still using the original hard and software from ZMAS. From hardware side he had the problem, everything was too complex. There were two PCs inside. One PC was starting, the second one remotely, and then communicating to each other. On the other hand, he had the original ZMAS software here, but he has only one CNC machine, but a lot of manual measuring machines. These manual measuring machines were running with Telcam PowerINSPECT, and the old ZMAS were not able to work with the other machines together. So that's the reason why he decided to change. Also, he had some problems with downtimes of the machine, because there were no spare parts for the electronic components of his own old controller. After the retrofit was finished, and we're talking here about 3 days, 2 days for the installation, 1 day for the calibration of the machine, he was able to work in a modern environment now with state-of-the-art techniques and also guaranteed spare parts. So if everything is going wrong, he can be sure, okay, somebody can help me. But why he chose Pantech technology here instead of anything else? Because first of all, he wants to have a direct interface to his software, so PowerINSPECT, and no additional drivers. This means he has no I++ server or something else in between, but he just starts the machine and starts PowerINSPECT, that's all. The next is the flexibility of the Eagle system allows him to keep the costs low, because, as I said before, he has special motors. On the most retrofits, the retrofitter will remove the motors and put new motors inside and throw the amplifiers away. And this comes to very high costs and also brings a very high downtime for the retrofit. With our system, he was able to have all the expensive parts still in the machine and can use them. So this allows us to have this downtime for only 3 days for the complete retrofit. And also later out, the proven technology of all parts should bring this downtime for him to a minimum. Although he was thinking about to add a laser system later, so he has now the possibility to easily upgrade to laser systems, SP600, whatever he wants to.
Okay, Joerg, thank you for the overview there of the customer and why he chose Pantech as a partner. So let's look at some of the reasons why the customer with the ZMS CMM chose PowerINSPECT as a preferred partner. First of all, the direct interface to the Pantech controller meant that this customer could keep his retrofit costs down, and it also meant there was minimal disruption to his inspection process. Furthermore, PowerINSPECT CNC was the preferred partner because of the full CNC capabilities. We've already spoken about the offline programming abilities in PowerINSPECT CNC, and this gave the customer the confidence that they could program their routine and that they could let the routine run on the machine with confidence that the points were going to be taken in the correct place, and there was minimal requirements for operator intervention. The customer could even specify that the results were output to a report at a certain point, or that reports are printed. One of the big pieces of functionality in PowerINSPECT 2015 that also attracts interest from the customer is the intermediate probe paths, which automatically avoid collisions and save time. Now, we're going to look at a demonstration in a minute which shows how this works, but this means that when the probe is moving between 2 points, that we can automatically ensure that the probe will not collide with the part. One of the other key benefits of PowerINSPECT is that the user can transfer inspection sequences across devices between our manual, CNC and OMV variants. So that's working with a range of devices from different hardware manufacturers. And the common user interface across those different variants means that training costs are kept down, and it's easy to transfer an inspection sequence from your CMM to an inspection on the machine tool with PowerINSPECT OMV, for example. In PowerINSPECT, there are automatically generated probing strategies which help to save programming time. So the points are automatically distributed when we select a circle, for example, or we can select a user-defined strategy and click where we want those points to be taken, or specify the number of points that we want to be taken for a geometric feature. So let's have a look at some of these things now in the videos. First of all, we'll just show the interaction between PowerINSPECT as a software and the Pantech hardware. So here you can see that the plane was probed on the front of this engine head, and that we then move on to show a probe head angle change, which we'll look at in a minute as to how you do that in PowerINSPECT. And then we look at probing some geometric features, such as the bores on the side of this model. Here we are, we can see the live hardware being driven by the software around the part. So very quick and easy to create those strategies. We're now going to have a look at an example of how we do that in PowerINSPECT. So first of all, we can use the wireframe checker to select the plane and to select the points on the surface of the plane where we want points to be taken. Here we only need 3 points for a plane, but if we do select 4, we can use the button on the left hand side to remove that last point. Furthermore, we need to look at how we change the probe head angles. Here in PowerINSPECT you can simply click the A and B angle and you can use the slider to change those angles, or you can directly input the values as figures. Once happy with those, we can click the tick and accept them. So in the sequence you saw that the plane was taken and then we looked at the circles. Now we're using an auto touch trigger strategy and the probing methods we're all seeing there in the drop down menu. Here we've decided that 6 points is too many for that circle and instead we wanted to change that to 4. It's also clear that the retract distance isn't enough for the circle, so we changed that again on the left hand side. And when we select that second circle there, you might be able to see here at the bottom left that the figures that we put in for the retract distance of 20 and the optimal strategy with 4 points, that they're all carried across. So in that alignment geometric group, any editing that we make is transferred across all of the features in that group. And we click the green tick to accept it, of course. Now PowerINSPECT can create constructed features as well as the probed features. So here for our alignment we're creating a line between the two circles and we do that very simply. Now there's something I want to show you about the probed plane on the right hand side. Here we use the wireframe checker to select the surface and we select our 4 points. Now there's an auto orientate button in PowerINSPECT. Because this plane's not perpendicular, we can use the auto orientate button on the left hand side, which will automatically orientate the probe head when it's taking those points. So you can see that it was automatically orientated there. Now there's one more feature that I want to show you that's key from PowerINSPECT 2015 and that we saw in the first video when those ribs were being probed on the engine head. So here we can see that there's lots of probe points here on the different steps of the rib and you can see the probe paths. As we click to simulate the sequence, PowerINSPECT highlights that there's a collision and the CNC detection avoids this from happening. The red arrows there highlight the brown lines, which you can see perhaps a brown star as well, which show where the probe is going to collide with the part. Now we've talked briefly about the automatic collision avoidance in PowerINSPECT, which saves you time when you're running the program and means that there's no operator intervention required. Here we can insert an intermediate probe path and you can see that those brown lines now have changed to green. So there we are, we circle it and you could see that line elevated so that the probe no longer collides with the part. So the operator's time is saved here, and rather than intervening with the inspection sequence, he can use his time on more valuable things. Okay, so last but not least, what should we look for in a software if we're considering a retrofit? Well, one of the first things that we need to consider is that the software needs to be easy to install. We don't want an interruption to our existing infrastructure and the machine electronics. Of course, if there's a direct interface between the controller and the software, then this will help to simplify the retrofit and to make it a quicker process. Secondly, when we're considering retrofit software, we want to have a powerful CAD interface. This means that we can simply click on the CAD to select features and that we can very quickly create our inspection routine. When it comes to reporting, we need the reporting to be clear. On-screen feedback should be able to be understood at a single glance. And furthermore, regular software updates are key when we're considering which software partner to take for a CNC retrofit. Why are they key? Well, it's because of the support and the enhanced functionality. If you've got regular software updates, that means you're regularly getting new features for your software package, which will keep you ahead of your customers and keep on improving your efficiency. And of course, if software is being regularly updated, it means that the company has a strong support network, which will help you if you get into any trouble. So Thomas, what should we look for in hardware?
Yeah, with hardware, it appears to be a bit easier, since the first step by comparing data sheets is quickly done. Further, insurers can give you a demo set for verification parameters mentioned in the data sheet. However, for example, when you want to compare controllers to each other, first of all, look at the servo loop times, because normally the shorter the servo loop times, the faster the machine can be moved. Also, we have mentioned that several times now throughout the presentation that look at the interface with the host software. Is there a direct interface, or do you need a cumbersome I++ server in between? Also important, looking into the future. What about the possible functionalities and also the flexibility in respect to upgrades for the future? Do you have to change the complete hardware if you want to upgrade, or do you just purchase the upgrade parts? Looking at the probe heads, of course, repeatability is very important. Also, rotational torques, because the higher the rotational torque of a probe head is, the more weight can be lifted. And this is especially important when you want to use, for example, a laser scanner or a long extension. And I've mentioned that before, when it comes to speed, of course, the position changing time is very important. How fast can the probe head change its position? Looking at the probing, point-to-point tactile probing, of course, this is common sense, accuracy, repeatability, and robustness. And for the tactile scanning probes, very important is the deflection range, the resolution, and the measuring range. The higher or the wider deflection range is, the better the scanning results normally, because and smoother the scanning process is, because the probe is not losing contact to the working piece. And for the resolution, of course, means more points, means better results, and more obvious analysis of the workpiece. So Michael, can you please summarize the last 20 minutes for us?
Okay, so to summarize what we've looked at today, a machine retrofit can mean that you get new sensors, controllers, or software to improve the efficiency of your CMM. One of the benefits of this is not only being able to increase your throughput by accessing new techniques, or to maximize your profitability because the costs of maintenance go down after the retrofit, but also the retrofit can be simple. You can keep all the costly parts of your existing CMM, as Joerg told us at the start, and experienced partners help to make this process simple. Furthermore, a direct interface between the controller and the software minimizes the disruption, and therefore there's minimal downtime, and you can get back to inspecting parts quickly. So that brings us to the end of today's webinar. Does anybody have any questions? If so, could you enter them in the bottom right hand side of your window, and we'll do our best to answer them. Thank you to all of the attendees for attending. You will receive an email thanking you for attending and offering you a download of this webinar in the next couple of days. So thank you very much.
Thank you.
Thank you.